You've built a real, multi-threaded web crawler using only the Java standard library. This code touches on concurrency, networking, URL parsing, and regular expressions, all fundamental skills for backend and data engineering. Now you can extend it with features like robots.txt compliance, distributed crawling, or content analysis. The entry point parses command line arguments with sensible defaults, 100 pages, depth 2, 2 threads, 500 milliseconds politeness. It then instantiates the web crawler and starts it with the seed URL. The crawl runs until completion, after which the program exits. Link extractor uses a regular expression to find all tags with an ref attribute. It captures the value inside single or double quotes, group 2. For each link, it resolves relative URLs against the page's base URL using the URL class. Malformed URLs are silently skipped. The result is a list of absolute URLs. PageFetcher uses HTTP URL connection to send a GET request. It sets timeouts, follows redirects, and includes a custom user agent string, to be a polite bot. If the response status is not 200, it throws an exception. The body is read as UTF-8 text and returned as a single string. The connection is closed in the finally block. A politeness delay is then applied to avoid overwhelming servers. Each worker creates a PageFetcher and link extractor, reused across tasks. The run loop pulls the queue with a 1-second timeout, so it can react to shutdown signals. When a task is obtained, it increments the active worker counter, calls crawl, and decrements the counter, and finally, crawl, fetches the page's HTML, marks the URL as crawled, updating visited to true and incrementing page count, extracts links using the link extractor, and adds them to the frontier with depth 1. A crawl task is a simple immutable holder carrying the URL to fetch and its current depth. It is used as the unit of work in the task queue. We roll back the visited entry. Add task first normalizes the URL. It uses java.net.uri to lowercase the host, drop fragments, ensure a path, and keep scheme query. If the URL is invalid, it's rejected. It then checks limits. If we've reached max pages or if the depth exceeds max depth, we skip. The visited map is updated atomically via putifAbsent with value false meaning queued. If the URL was already present, we skip. Finally, a crawl task is offered to the blocking queue. If the offer fails, unlikely. Start first adds the seed URL with depth 0. If that fails, e.g., already visited or limit reached, it exits. Then it launches number threads workers, each an instance of the worker inner class. The main thread then enters a waiting loop. It sleeps half a second, checks if shutdown was triggered, or if the page limit was reached, and exits when no more tasks are queued and no workers are active. Finally, it shuts down the executor gracefully. Constructor accepts configuration, maximum pages to crawl, maximum depth, number of worker threads, and a politeness delay in milliseconds between requests. It initializes shared state a concurrent hash map to track visited URLs, mapping URL to a boolean indicating whether crawling is complete, a linked blocking queue as the task frontier, a thread pool via executors, and atomic counters for active workers and crawled pages. The shutdown flag is volatile because multiple threads will check and set it. We